First Spin. Welcome to First Spin, a show where I learn how to use the Parallax propeller without having any prior programming experience. Rather than do this on my own, I have enlisted the help of Whisker and Roy.
Hello.
Howdy.
So,
Looks like we trained you to stop calling us experts.
well, because you guys always give me grief about it. So I have learned my ways. I have been conditioned.
Well, at this point, I think you're the expert, so
Sweet.
you're going to answer our questions this week.
Not gonna happen. Quit. Abort. Which actually
Those
happens
are
to
both
be.
commands coming up soon.
I know. That's why I used it. Isn't that clever?
Now, could you explain those to us, please, Addie?
It exits from your repeat loop. Bam. And it stops. And it aborts. And the rest is up to you guys.
Well, at least that was a short explanation.
I know. I'm very succinct.
She
terse.
read the manual
I
that's
used-
right in front of her face right now.
I used a bite-sized explanation.
Because right next to the keyword quit, it says exit from repeat loop. In the manual.
At least I didn't say P186.
Yeah.
What? So, last week we finished looking at process control, cog control, flow control. And this week we were going to start with repeats.
Yeah, we were only halfway through the flow control stuff. We covered the if and if not and case stuff, but now we're on repeat.
Oh, I
And
guess repeat is still considered flow control.
yes,
I see.
because you're
Okay.
creating loops.
I see. Okay.
And a loop is a flow control, of a special variety.
Right. It's like infinite loop.
Well, it can be infinite, or you can add some of these other little keywords like from and to, or until, or while, and make it not infinite.
Okay. So oh, go
go
ahead. Oh. We're just so polite today. So I've used repeat a whole bunch of times, and I think it was in the most recent project that I've worked on, the RC Servo, that I actually did the what's it called? The repeat 100. So it would repeat 100 times and then move on to the next thing.
Yeah. So the two most simple forms of repeat is repeat without anything after it. It'll just repeat forever everything that's indented underneath it.
Yeah.
And then repeat and a number will repeat the stuff indented underneath it that number of times. So repeat 10 will do it 10 times.
Okay.
Repeat
And that's all
100
you
will-
had to do. You just had to put the number.
Right. That's the two simple forms.
Okay.
You can do a more complicated form. For example, you could say repeat until, and then some condition like my variable equals some value. So say you have a variable that you initialize to 0, you have x colon equals 0 just above your repeat. And then you could say repeat until x equals 52.
Oh.
And then inside the repeat loop, you could do something to x to change its value, incrementing, decrementing, whatever. And when it equals 52, it'll drop out of the repeat loop.
And then it
And
just goes to the next loop, whatever
it goes to the
happens
next
be.
command after the repeat.
I see.
So when you have a repeat, anything indented under it, as
Yeah.
you'll see in the prop tool, creates those little gray lines connecting to the stuff that's indented.
Mm-hmm.
And that stuff is what will be repeated.
I see.
And then the next line after that isn't indented in is the next statement,
Command. Okay. Got it.
afterwards.
Okay.
So the other variations of repeat where you have until or while, and so until and while are basically opposites of each other.
Mm-hmm.
So repeat until x equals 52 is saying keep going until x equals 52,
Then stop.
and then drop out of the repeat and go to the next thing.
Right.
While is saying repeat while the condition is true. So if you said while x equals 52, it would only do the repeat loop when x equals 52.
That's very interesting because so that means I could, well, I'm trying to think of my heart project, and I'm thinking would it make sense ever to do repeat while case state colon equals 1. Does that make sense? And then
Well,
when the switch turns
But it wouldn't be colon equals. It would be
or equals.
equals.
Okay.
The double equals, because that's the comparison equal. Whereas colon equals is the assignment equals.
Oh, I see.
We talked about this last
We've
time.
talked about this in the past.
Well, yeah, I know. It's been a while.
But there's some other important things to know about the until and while cases. So you can do the until and while on the line with the repeat. So it'd be like repeat space while expression,
Right.
whatever your expression is.
Sure.
Or you can do repeat, have stuff indented in, and then have the while at the bottom, at the end.
Oh, and that'll equal the same thing. Or no?
It's similar. What the differences are subtle, but it has to do with when it does the check for whether it should exit the repeat or not.
I see.
And also just sometimes it won't have much difference at all, but it'll just, some people think of it different, like they like to look at it differently on their screen.
Yeah, for people who've been coding for a long time, you may have seen stuff like that in do until or a while when loop.
Right. And one of the things that's also important is it determines like if you did repeat while x equals 52 and before getting to that line x wasn't equal to 52, then it wouldn't do anything inside of that repeat loop because x doesn't equal 52 and it does the check right at the beginning. Whereas if you do repeat and then a bunch of stuff and then while x equals 52 or until x equals 52, it will do the stuff in there once
and then
do the check and either repeat it around or fall out. Okay,
now say it's at 51 at this check. Does it just go to the next thing?
Well,
obviously depending on your command. So say it's repeat until x equals 50, right? And it's 51. Right. Then it'll check and then see and then go next.
It'll keep going because x doesn't equal 50.
Right? Whatever said, if it's
greater than. I said until. Never mind. Right. Okay. It's like it's like a freaking English course in here. Okay, I get it. Just being
there's also another little bit simpler, but it's a little more wordy version, which is the from to step variant.
Okay. Which is how I roll.
I see.
Go ahead.
Yeah, repeat index from 0 to 255. For example, would go through the loop, and the first time it goes through, index would be equal to 0. Second time, it would be equal to 1, so on and so forth until it got to 255.
Now, can you say repeat from 0 to 255, step 2, and then it'd go 0 to
every
4,
other
6?
Number. Right.
Yeah. And it can step backwards as well. If you do from 255 to 0, it'll automatically do your delta as a negative.
Right. And you can also do from any value to any value. So like you could go from 5 to 31.
I see.
Or from 30 to 1. And it will appropriately go backwards or forwards automatically.
I much prefer those kinds of loops because they're less bug prone than some of the stuff you run into with while and until. Because you can run into some strange things with those.
Now, what if you wanted...
go ahead. One case for just defending the while or until case is if you're doing like some kind of user input and you want to have them type characters and then hit enter, you could do the input in a repeat loop until they've hit the enter key, right? You could have the condition check that is when they hit the enter key, fall out. And that wouldn't really be possible to do with a normal repeat loop or from to loop. Easily. I mean, you could still do it because you can use some of the commands we're going to get to in a little bit to fall out of the loop early, which is the quit command, which we were talking about earlier, exit repeat loop. So in more complicated versions, you can do that.
Now, say you wanted to repeat the same sequence, but like, say 1, 2, 3, and 5. At steps 1, 2, 3, and 5, would you have to make like
If you don't
Would you
have
be able to?
a regular sequence that is able to be calculated via a formula or
Yeah,
something,
yeah.
then it's kind of hard to do
With repeat.
with repeat.
Okay.
I mean, unless you're talking about a standard step size, then repeat will not really work for you in the same, using the from to. Now you could do a repeat that's infinite and have logic inside of the repeat that was doing if checks, right? Like you could have a formula that would increase your index value inside of the repeat to go 1, 2, 3, 5. Some you could, or 1, 2, some sequence.
Right.
You could have a complex sequence, and then you could have an if check inside of the repeat loop that would check for your end condition and use quit to get out.
I see.
You can do really cool things with this. Like, for example, if you wanted a complex pattern that you wanted to step through, you could do a from to within an index variable and have it step from 0 to 255, for example. And down in your data section or up in an array of longs in the var section, you could define a data structure that has 255 elements in it.
Mm-hmm.
And then as it steps through 0 to 255, it's actually using the 0th or the first or the second or the 255th element in that big data array, and it pulls out something big and complicated out of that and uses that specific thing for that particular step.
Wow,
right.
That's pretty.
So
it's really useful.
That technique is typically called array indexing.
I see. That makes sense.
And so you're indexing an array with your counter that you're incrementing in the repeat. And the counter is, like, in this case, we used index from 0 to 255. So then, like you said, you could have a sine wave in your data table, right? And you could read the values out of it in a repeat loop by doing that.
That's very cool. I didn't realize repeat was so powerful.
Yeah, it's one of the most powerful pieces of the spin language, in my opinion.
I am repeat.
Yeah, you can do almost anything with just repeat and case, and you've covered almost all your bases with just those couple of things.
That's cool.
Yep.
Okay. Next. Next. Let's talk about next.
Yeah. So inside of a repeat loop, if you have
quit it, you guys.
a very long, you might have a simple thing, but you could have some complicated logic inside your repeat being done every time, and you might decide partway through that code that you don't want to do any more of the rest of the stuff in the repeat. You just want it to start back over again at the beginning of the repeat section. That's what next will do. So if you say next, it'll skip any code that's on the lines after the next.
Oh, I see.
And go back up to the top where repeat's at and do the next. So like if you were counting from 0 to 255 and at 128, you go, if x equals 128 next, then it would skip and come back up to the top and do 129.
Oh.
Right?
Okay.
That's just an example.
I see. Sure.
It's basically skipping the rest of the stuff.
Sure. Okay. I got it. That makes sense. That's useful.
Right. And then the very next one, quit, is similar, except that instead of going and doing the next one, it stops the whole loop.
It's like GG no re. Got it.
Right. You just drop out and do the line that's after the repeat block.
Got it.
When you do a quit.
Got it. It's very useful. I like the slow control.
Yep.
Okay, and then return and abort.
So return is just if you have your pub or pry function that you've written and you want it to return a value to whoever called it, you use return to return that value.
We talked about this a bit last time. It can be a little bit of a complicated subject. I don't know if you really understand that, Addie. That in a function that you call from another one, it can return a value when it's done.
Sure.
Makes sense to you?
Yeah. It's like solving the equation and then giving the equation to something else. You're returning that equation solution to something. whatever it may be.
Sounds like
Right.
you get it.
I got it.
Right. So one other little spin specific thing related to this return concept is that by default, your function will return a value called result, which is an automatic variable that will just automatically be made for you if you don't make one.
Huh.
So if you just in your function say result : equals some value, then that value will be returned.
So then if you were to hook up the Parallax serial terminal, right, and you wanted to see the results of, I don't know, the amount of voltage or something that a solar panel was sending back, right? And you were, measuring that via ADCs. Is that
Right.
that's which I think is possible. So then you would just do result : equals.
In your function that read the solar panel through the ADC, it could say result : equals the resultant value, right? Like voltage in integer, right? Then when you called that function, that's the value that would get returned. It's just sort of an automatic mechanism that they build into Spin. You can override that with this return command and return something else.
Okay. And then so you could just use this return, and then your PST would show, say, the amount of voltage that the solar panel was seeing at a given time.
You're missing a lot of glue in between the things, but yeah.
Right. There's a whole big complicated amount of stuff going on there. But yeah, the basic idea there is you have a function that will read your solar panel and it returns the voltage back to you.
And where it's returning it is going to pass it along to the, through your serial terminal so it shows up on your computer screen.
I see. Serial is still a bit of a conundrum to me.
Yeah, therefore you shouldn't use it in examples.
Sorry. But it seems like everybody uses it for everything.
Yeah, it's been around forever. It works.
So LCDs use it. Did we use serial communications in the RC Servo? I know it's pulse with modulation.
PWM.
So that's pulse with modulation. That's different from serial.
Yep.
Oh. All right. I didn't know if PWM was a type of serial. No. But I digress. Let's abort that situation, that issue. So speaking of, so after you return values and such, then we got abort.
Okay, so abort is kind of a special case thing. I mean, I have rarely used it, but it can be very handy. And what it does is very similar to return, but a little more strong. It causes it to, if you say you called from your root function, the first one that gets run when you run your spin program, you call a function and then that function calls another function and then that function calls another function. If the last function did an abort, it would return all the way back up all those functions back to the first root function. It causes it to basically skip out on all that stuff and go back to the beginning, back to your root.
Wait, that's what abort does?
Yes.
Oh, okay, abort, I see. So
abort is usually a mechanism for saying something bad happens, so we should exit out of the program.
Right.
Or at least exit all the way back up to the main loop or the main
and then start over
function so it can react.
So it's like resetting your settings to default.
Not exactly.
Oh.
It's more like it allows you to not return back up if you called those several functions in like I explained a minute ago, and you just did a return, it would only return back to the function one back. Right, that called the last one.
Sure.
And if it was in a bad situation, that function won't know it's in a bad situation easily. Whereas abort causes it to bypass those and go all the way back up.
I see. And start over.
Right.
Right. Okay.
Well, not start over. It just takes you all the way back up to the place where you called all the way down in to that, from the main starting function.
I might need another example.
Okay, let's do a little bit simpler one.
Okay.
Say how you have your main function that's the first one that starts up.
Right.
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 Then it calls function 1.
Yep.
Which is doing something.
Right.
And then in function 1, it calls function 2. And function 2 is like, read the solar panels and give me the voltage back.
Mm-hmm.
Okay, but in function 2, if it determines an error that it should, you should abort, then it can abort instead of return. And instead of going back to function 1, it'll go back to the main function where function 1 was called from.
Okay, and then, so the main will then run, and then the function 1 will run again, which will then call function 2, which is the solar panels and all that.
Right.
Okay.
And so it'll go back to where it was, and you can detect that the abort happened because it'll be an abort state.
So it's like a kid that butt in line at the cafeteria of the school lunch, right? And then it was said, and then the lunch lady said abort, and then the kid has to go back to the back of the line.
Right. So
Got it.
Abort. The other thing is that abort is typically used with what they call the abort trap, which is when you call a function that may abort if you put a backslash in front of it. If the abort occurs, that will result in true, so you can detect that the abort occurred.
How do you detect?
So you would say, like, if you have your get voltage function, right? You would say if backslash get voltage, then what would happen is the get voltage, if it aborted, would return true in that case with the backslash in front of it.
And you could trap it.
And then you could do something else as a result.
This is a good opportunity to introduce Addie
instead of starting from step 1.
The idea of error traps.
Right.
When you start allowing, especially user data, like users to input information into the program, you want to make sure that you build in error traps for in anywhere where anything can possibly go wrong,
but that's
and even in
step.
places where you don't think it can go wrong.
But that's every step.
Yeah.
Well, that's kind of obnoxious.
Well, sometimes you don't need to put things at every step. You just need to put things at important steps that could be, very problematic if you don't react to them appropriately. Like in the example in the manual, they have a usage where they basically they're driving a robot around, and they basically tell the robot to move, and if the move function aborts, then it'll beep. Right? Because the move said I couldn't move, and it causes it to beep. So that's like an example of using the abort.
I see.
And really what happens in that one is that the move function calls a separate function that drives the motors, and the drive motor function aborts and falls back all the way to where it called move, and then move goes, oh, it was an abort, so I'm going to beep. Whereas if it wasn't an abort, it doesn't beep.
Gotcha. But this is something that you'd have to write into your code. You
build it into your code.
It's not like brownout or anything.
Right. You build this into your code to make it handle bad situations.
I see. Okay.
And like I said, I've only used it in a few cases, and some people like Whisker would probably say I should use it in more cases, and he's right.
Yeah, there should always be more error trapping in all the stuff that we do, but a lot of the times it's just a prototype thing that you're doing for yourself, so you're like, I'm not going to put any stupid input into it, but as soon as you hand it to other people, they will do things with it that you just never would even dream up that they would do wrong, and they will crash it in brilliant, spectacular fashion.
I can do it. I'm a great alpha tester. I can crash just about anything.
And just to be clear, you can do error trapping without using this abort feature of the language. The abort feature just allows you to do it in a nice way. In some cases, where in a little bit cleaner way than you might have to if you didn't have the abort feature.
Gotcha.
You can also just check for error conditions yourself and react right where you check them, which is what I tend to do in a lot of cases. But it's one of these things where the abort is like a feature of the language that helps make things a little easier and nicer.
Gotcha. Cool.
All right, Addie. So you mentioned before we started that you wanted to talk a little bit about what you were doing with continuous rotation servos this week.
Yeah. So we got a whole bunch of really great sensors and peripherals from Parallax, and thank you, Parallax. And one of which was the continuous RC servo. And so it's the first time I've worked with anything like that. In fact, I didn't really know what a servo was. I just thought it was the spinny thing, but actually it's the system behind the spinny thing. So I looked at the PDF that was provided with, on the site. And Roy, I don't know what it is. I think there are cached pages online that have different versions.
Oh yeah.
I don't know. I'm not quite sure because I think I've seen two different website versions of the Parallax page associated with the RC servo.
Yeah, I wouldn't be surprised if they had an older one that got updated and somehow you still got a link to an older one that was still there.
I don't know. So I looked up, I just Googled Parallax RC servo, I think, or maybe searched on it on Parallax. Anyway, got the code, and the code was confusing, actually. And it wasn't written properly, like there were bits that were missing, and so I don't know. I'm guessing it had to have been a draft. That's my guess. But it gave me an opportunity to troubleshoot the code, try to understand what they were trying to get at in the code, and then write a better code for myself.
Yeah.
Yeah.
So at the end of the day, Addie ended up writing her own custom continuous servo driver.
Correct. But I do have a couple of questions.
Okay.
Okay. All right. So
quickly.
Right. FRQA. What is that?
Okay, that's one of the special purpose registers, and it's for frequency A.
Yeah.
And it's used with the counter A register to allow you to set the frequency at which it does things. So
like, is that like 1 hertz, or is that?
Well, it's configurable. So if you configure the counter into a certain mode, and then you set the frequency, and the frequency is going to be like, in one example, you'd set a frequency and it would count down until it got to 0 from whatever frequency was, and then it would trigger. But it depends on the counter mode as to how frequency is used.
Now the counter I see here is 30.26. Now is that referring to pins, or
those are pins
bits?
30 through, or bits 30 through 26.
Bits.
Where?
Right. Where are these bits?
In that register.
Oh.
Right.
So just like with in A, out A, DIRA.
But those are for pins. Those you
Right.
address pins. You don't address bits per se.
There are also bits in memory too.
Well, I guess so.
So.
Right.
I mean, but I guess to me it's just more tangible when they're pins that,
It's bits.
They're just each register has a 32-bit memory address that is.
Oh, and you can address each of the bits to like configure it.
Right. So when you're setting up your counter A settings, you can set some of the bits to equal a certain value and other bits to equal different values.
And that's different modes.
Right.
Oh, okay. So I got a question. The CTRA 8.0 equals servo pin, which in this case was 0.
Right. So the lower 8 bits or 9 bits
are all 0.
8 bits, sorry. Are which pin is that counter going to trigger or read or do something with? Depending on the mode, it will like if the counter is counting how many times that pin goes high, then it'll read the pin, and every time it goes high, it'll count up 1, right? But if that, maybe that, like in the case of the servo, it's driving that pin at a certain pulse rate, right? So you're telling it which pin it should drive at that pulse rate in that lower 8 bits. Or
so
bits.
the pin that it's supposed to use is set with a binary number over just a couple of the bits there, just 8 of them. Make sense?
Right.
All right. We're out of time, though.
Epiphany.
So,
that
you
makes
good?
sense.
You good?
I'm good.
All right. Now, we have something important this week. Parallax, who kindly sponsors the show, has requested that all of you guys, all of you listeners out there,
Everybody,
let them know if you like this show and if you want us to keep doing it.
Yep.
Email them, call them, tweet them, whatever you want to do.
Repeat them.
But let them know. Because
repeat until.
You guys are all very polite and you haven't said much about it. But we can see how many of you actually listen to the show, and there's a lot of you. So let them know, and we'll be able to keep doing this for a while.
Yes.
All right.
Yep.
So that's it for us for this week. You can find this show every Tuesdays at firstspin.tv.
See you guys next week.
Bye.
Bye.
Bye.